Geometric series. This goes with 10.1c notes. Our objective is to find the sum of the finite geometric series using a formula. Here's the formula for the sum of a finite geometric series. Remember that the word finite means that the series has a certain number of terms. It does not go on forever. Or finite means we want a certain number of terms summed. Just a reminder that a sub 1 still means that that's the first term. And r is our common ratio. That's what we're multiplying by. So consider the series 1, 5, 25, 125. Notice the difference between a sequence or a pattern of numbers is listed like 1, 5, 25, 125. Whereas the series has the plus signs in between. So I can tell I have a series here. Find the sum of the first 10 terms means that n is going to be equal to 10. I want the sum of the first 10 terms. So S sub n is 10 terms. So a sub 1 will be the first term in this series is 1. R is our common ratio. So how am I getting from 1 to 5, 5 to 25? I'm multiplying by 5. So R is 5. And so I have everything I need to plug into my formula. So the sum of the first 10 terms would be S sub 10 will equal 1 in parentheses, 1 minus 5 to the 10th power over 1 minus 5. So I plugged in 1 for a sub 1, 5 for r, and 10 for n. Now we do have to follow our order of operations here and evaluate what's in the parentheses first. And I always evaluate the denominator here. So I simplified that, which is 1 minus 5 is negative 4. Then I'll evaluate what's on the inside and then multiply it by 1. So I'll do the top first in my calculator and I'll go 1 minus 5 to the 10th power, parentheses, then divide that by negative 4, hit equals, then multiply it by the a sub 1. In this case, a sub 1 is equal to 1. So it's not really necessary there. I end up with 41406. It's from the calculation that I did previously. So this is the sum of the first 10 terms of this geometric series. So let's try another one. This time I want the sum of the first 12 terms, and my series is 1, 3, 9, 7. So I am going to need my first term will be 1 again. I want the sum of the first 12 terms, so n is 12. And r is what am I multiplying by? So from 1 to 3, that's times 3, 3 to 9, times 3. So r is 3. So the sum of the first 12 terms, S sub 12, will equal 1, parentheses, 1 minus r to the n will be 1 minus 3 to the 12th over 1 minus r, which would be 1 minus 3. Simplifying the denominator here first, I get 1 minus 3 to the 12th over negative 2. And then I type this in my calculator first, hit enter, then divide by negative 2, then times 1. And I ended up with 265,720. That'd be the sum of the first 12 terms of this series. Okay, so I think you get the gist of that plugging into the formula. Let's move on to a word problem example. So Mr. Smith likes writing lots of exam questions. He usually starts out this semester with only 10 questions on the first exam, but for each subsequent exam, he writes 1.5 as many questions as were on the previous exam. How many questions are on the 5th exam? So in this is a series, we have 10 questions on the first exam, Let me highlight that. That right there is giving me my first term of this series, 10. Then it tells me that I write 1.5 as many questions each time. That's giving me my R. R is going to be 1.5 times as much each time. So I start with 10 times 1.5 is going to be 15. So on the second exam, there's 25 questions, the sum of those two. And then 15 times 1.5 will be 22.5. And then it'll continue like that. So I want the sum of the first, or to figure out how many questions were on the fifth exam. So what I'm really looking for is the sum of the first 5 terms. And so I can use the formula to help me out here. Just a reminder, it's S sub n equals A sub 1, 1 minus r to the n over 1 minus r. So A sub 1 is 10, and 1 minus r was 1.5, and we wanted the fifth term, the sum of the fifth term, so n is 5, and then 1 minus 1.5. So simplifying here, I get 10 over 1 minus 1.5 to the fifth over negative 0.5. And then I calculate this first, hit enter, this one next, divided by that, and then times 10. So that might look like this in the calculator. 1 minus 1.5 to the fifth in parentheses, then divided that by negative 0.5, hit equals, then times 10, then equals. And my answer I got was 131.875. So I would answer this to say that there would be approximately 132 questions on the fifth exam. So hopefully that includes some multiple choice, because that's a lot of questions. Let's try another one. A culture of bacteria doubles every hour. If there are 500 bacteria at the beginning, how many bacteria will there be in 24 hours? This is kind of a scary truth. So we start identifying some key pieces. There's 500 at the beginning, so that's our first term of this series, 500. And it says that they doubles every hour. That means that they're being multiplied by 2, which means that our common ratio, or R, is 2. So our series will look something like this. And the first term is 500, then it doubles. So then the next term is 1,000. So after 1 hour, there's 1,500 bacteria. Then that doubles again. And now we have 3,500 bacteria after the third hour. And so I want to know how many after 24 hours. It'd be very tedious to continue adding this up. So using our formula, where S sub n equals A sub 1 times 1 minus r to the n over 1 minus r, where these are our key points. 500 goes in for A sub 1, and 1 minus 2 to the 24, because I wanted S sub 24, the 24 hours, over 1 minus 2. So really that's 500, 1 minus 2 to the 24th over negative 1. So maybe I'll show you what that might look like in the calculator this time. Here, my calculator. So like I said, I would put this in parentheses first, and I would do 1 minus 2 to the 24th power. I have to arrow out of that exponent and close my parentheses. Then I would divide that by negative 1. I'd hit enter, get that number, and then times that by, times that by 500. That's what happens when you have free apps. And this actually gives it to me in scientific notation. So remember that times 10 to the 9th means that you're going to move this decimal point over 9 places. So My answer was 8, 388,607, 500. So we got thousands, 100,000s, millions, trillions, 8 trillion or so bacteria after 24 hours. That's a lot of bacteria. Okay, so all you gotta do is find the key pieces that you need for the formula and plug them in, and then make sure that you put them in the calculator correctly. Thanks for watching.